Heuristics exist in both good and bad forms. In everyday life, you're already a master of heuristics. 1 plus 2 equals, give me the answer. You know the answer. How did you learn it? Well, what do you understand about the expression which is gained from heuristic? If I said the answer is 1, can you see 1 plus 1 equals 1? You guys know it's wrong. Why? Could it be that your brain looks at the plus sign and understands it to be addition? Yes, you see addition through association. In fact, if I changed it to the word plus, like so, 1 plus 2 equals 1, you'd still know that because plus is a plus sign and you have that association. You would still know the expression is wrong as well, right? 1 plus 2 is equal 1 is obviously wrong. So your brain learned a long time ago that if you take two numbers with a plus, the answer cannot be the same as one of those numbers. Now let's think about that. It's not the same. So 1 and a 2, the answer cannot be a 1 or a 2 when a plus is used. Now you might not think in that way, but that is one way of thinking about how a heuristic would work. You would say, what is the heuristic here? Well, 1 plus 1 is obviously 2. It cannot be 1 because 1 is used. 1 plus 2 cannot be 1 or a 2 because 1 and 2 is in the expression. It has to be greater than the highest number in the expression. Like, you know, this is a kind of heuristic way. So this is how I've written it here. What if I gave you a simple heuristic version of the mathematical expression? When you see a plus, the answer cannot be any of the digits used, 1 or 2. The answer must be greater than any of the individual digits. It must either be greater than 1 or greater than 2. So imagine that was the heuristic. Okay, so if you knew this guidance, you could apply brute force and take the first number greater than the highest number. We know that in 1 plus 2, the highest number is 2. So therefore, brute force, take the first number greater than the highest number, which is 3, and try that against the mathematics engine. Imagine an engine that says, yes, this is right or this is wrong. It's giving you the answer. Well, the first case in this basic example, your first guess would be correct. So the use of a heuristic, and by the way, this feels like it's more complicated than just understanding 1 plus 2. However, your brain has to build those associations, and when you were very young, you were building those associations. Whether you know it or not, and whether they are these associations, I am not a neuroscientist, I couldn't tell you, but this is the idea behind a heuristic. A heuristic, right? If you only knew this guidance, you could apply brute force and take the first number greater than the highest number, which is 3, and try that against the mathematics engine. In this basic example, your first guess would be correct. Now, you can't go around expecting that the heuristic is perfect. You can't say it's greater than those two numbers and then expect it to be correct. You can't simply say 10 or 1 million. There are infinitely many possibilities of being wrong. However, it helps you know what it's not. You know that it is not 1 and it is not 2. In fact, you know it's not 0 or minus 1, an infinite amount of negative numbers. One could argue that the heuristic version of this mathematical expression has solved 50% of the problem by eliminating 50% of the numbers. Think how powerful that heuristic actually is. Right? It's eliminated out of all the possible numbers in the universe. It's basically reduced it to 50%. You're in the other 50%, right? You're 50% onwards on being correct. It's great. This is cutting the problem in half, right? What if I gave you the following addition to the heuristic, right? To bring you closer to the truth. The answer would contain the number of digits in the equation divided by 2 plus 1. The number of digits. For example, 65 plus 99, 4 digits. 65 has 2 and 99 has 2, right? You see that. The answer will be 3 digits, right? Because we're saying divided by 2 plus 1. So that would be 4 divided by 2 plus the 1. Try this with a larger number like 99,999 plus 99,999. Well, that's 10 digits. You can see there, 10 digits. Divided by 2 is 5, plus 1 is 6 digits. Is the answer with 6 digits? And you'll find that yes, it is. Well, is it? Well, I don't know. According to our first rule, the answer must also be greater than any of the 2 numbers, therefore greater than 99999, right? The answer must be in the range of 100,000 to 999,999. You've drastically reduced, right? This heuristic has reduced not just the 50%, but a tiny, and because numbers are, I'm not a mathematician, is it unlimited? Right, so that other 50% you can reduce now to just this range, right? This range. And that's not bad going. We have eliminated most numbers in the universe. We now have a much smaller subset. This is a heuristic. It's not the truth, of course, but it can provide some guidance towards the truth. For this example to be properly understood, you should let go of the fact that you already know the answer, right? You already know, you got to remember that, right? This simple equation is so embedded in your brain and that it is automatic. You don't need to think too hard with addition, but if I increase the expression again and again, more of us would take longer and longer to get the answer. This heuristic could be quite helpful to at least find a range, right? So if you have a very, very difficult problem, you could see if this problem was how to figure out a design for a piece of software, you could have some heuristic, some rule, and then you apply those rules and you come up with an answer, and that answer is close. Right, is relatively in the right ballpark. There it is, 45 plus da-da-da. What if I give you those, right? Can you utilize this heuristic to work out what it might be? And I say here, I feel sorry for the trick I'm about to play on you, but it's important for remembering that heuristics can fail hard. If you follow the heuristic for these numbers, the heuristics will fail you. The heuristic is wrong. Why? Because I invented a flawed heuristic. What I went and done is created a heuristic that only works with 2 parts of an expression. Right? A simple 99 plus 99 plus 99 will break it. According to the heuristic, the answer would be between 1,000 and 9,999, but the answer is 297. Right? So it doesn't fall. The heuristic is broken. So just as useful as a heuristic can be, you can fail dreadfully hard in using it. And that is the caveat. You've got to understand that it's a pro and con scenario, that you may reach some kind of value or outcome that is good and you may not. You must understand the heuristic well enough to understand what you're doing. Here lies the good and the bad of the heuristic. Always assess the context of the heuristic. Always use it within the provided context. Understand the flaws in the heuristic. Very, very important. I'm going to end now. Don't want to read you the whole book. Don't want to read you the whole chapter. Will take forever. This is the nature of the book that I'm busy writing, looking at heuristics. Heuristics is not truth, but heuristics is a really, really good, think of it as a good bias, right? So you have availability bias, and then you have this kind of heuristic bias. And it can be used positively. You can put a whole lot of things in a pot, and then you can stereotype, right, as a type of heuristic, and then you've got some kind of answer, and then you can look at edge cases, and that can be a very good way of designing. So I hope you enjoyed this. This is just a little insight into the book that I'm writing. This is actually volume 2. Volume 1 is already available for free, and you can check in the description. You can download it in its PDF form for free, right? Please spread it around, send it to anyone you feel would benefit from it. Don't forget to click that like button and that alert, that notification bell, to be alerted of any videos that I add, and I'm trying my best to add as many videos as possible. Thanks for watching.